In this video, we're going to discuss why the sine rule for triangles, which is used to calculate the values of angles and edges of a triangle, must be true. Let's do a recap of what all these letters mean. The lowercase blue letters give the value of the edge that they are next to, and the uppercase yellow letters give the angles of the triangle. Each lowercase letter marks the edge that's opposite the angle with the same letter that's uppercase. So for example, the edge with a lowercase a is opposite the angle which has an uppercase a, and so on. And the sine rule shows that for all angles in a triangle, sine of the angle divided by the length of the opposite edge will always give you the same result. So sine A over A, sine B over B, and sine C over C have exactly the same value, and we're going to show why this must be true. Let's begin the proof by drawing a line perpendicular to the base A, which passes through the opposite angle A. Since the line is perpendicular to the base, then the angles at the base, either side of the perpendicular, must be 90 degrees, and therefore we've created two right-angled triangles. And the perpendicular line is the height of both triangles. Now, because the height is the height of both triangles, we can express the height in terms of the angle B and in terms of the angle C. Hopefully you will remember that the sine of an angle is equal to the opposite over the hypotenuse. So if we start with the angle B, well, sine of B is equal to the opposite over hypotenuse, but in a triangle that contains the angle B, the opposite is height, and the hypotenuse is the edge C. We can repeat this with a left side triangle with the angle C. So sine of C, that equals opposite over hypotenuse again. Opposite again is H, but this time the hypotenuse is the edge B. So we have two equations that can be used to get the value of H if we rearrange them. Now, if we look at the equation that contains sine B and I multiply both sides of it by C, we get C sine B on the left hand side and H over C times C. Well, the C's cancel and we get that C sine B equals the height of the triangle. And if we repeat the same process, or the equation that contains sine C, and multiply both sides by the denominator on the right hand side, we get B over B on the right hand side, and we get B sine C on the left hand side. The B's on the right hand side cancel, so B sine C equals H. That must mean that C sine B is equal to B sine C. If I divide C sine B by C, I also have to divide the other side by C. These on the left hand side cancel. So that means that sine of B equals B sine of C over C. If I divide the right hand side by B, I have to divide both sides. Well, on the right hand side the B's cancel, and on the left hand side we're left with sine B over B. And now you can see that sine B over B is the same as sine C over C, and that confirms part of the sine rule. But we haven't finished yet. We need to deal with the angle A and the edge A. I'd like to point out that I didn't choose the A edge as the base of the triangle because it has anything particularly special about it. I easily could have just picked the B edge as the base or the C edge as the base. And so the perpendicular line that we used to create two right-angled triangles would have been in an entirely different position. For example, if B was the base, then I would draw a line that is perpendicular to B through the opposite angle. And again, it would result in two right-angled triangles. The height of the triangle would have been the perpendicular, and then the height of the perpendicular would be given with respect to A and C rather than B and C. Which means that if we change the base and the position of the perpendicular, we should be able to get a comparison between sine of C and sine of A. So let's rotate the triangle to make B the base. So now let's draw a line perpendicular to the base through the opposite angle. And so this results in two right-angled triangles where the perpendicular is the height of both triangles. And let's not forget to give the perpendicular the value of h for the height of the triangle. And I've just changed the color of the perpendicular so that we don't get confused with the colors of the angles. And now we can find the values for sine of A and sine of C. So we know that sine of the angle is opposite over hypotenuse. We don't need to write that again. Sine of A equals the opposite, which is h. And the hypotenuse this time is C. And now let's find the value for the sine of C. So sine of C equals the opposite, which again is the height. This time the hypotenuse is A. This leaves us two equations. Sine of A equals h over c, and sine of c equals h over a. If in the equation that contains sine of A we multiply both sides by c, we get that c sine A equals h over c times c. But the c's on the right hand side cancel, and that leaves us that c times sine of A equals h. And if we do the same thing for the equation that contains sine of c, we can multiply both sides of the equation by a. Then on the left hand side we get a times sine of c, and on the right hand side we get h over a times a, and the a's cancel, and that gives us the result that a times sine of c equals h, which must mean that c times sine of a is the same as a times sine of c. Now what we have to do is rearrange the equations slightly. Let's start by dividing both sides by a, and on the right hand side the a's cancel, and then we can divide the left hand side of the equation by c, but we also have to do it on the right hand side, so the c's on the left hand side cancel, and we get that sine of a over a is exactly the same as sine of c over c, which means that it is equal to the right hand side of the equation that we found earlier, which means that we can simply put an equal sign to the right of the formula sine of c over c and move sine of a over a next to it because they are equal. And there our proof is complete. Sine of b over b equals sine of c over c equals sine of a over a. So thank you for watching. Until the next video.